BigQuery data warehouses can have a ton of unstructured data, tables of customer reviews, product descriptions, support tickets. There is a lot of value in that data, but if you can't standardize it or filter on it, then the value is just going to sit there. I'm Billy Jacobson, a developer advocate at Google focusing on generative AI and data. Today, I'm going to show you how to use the new BigQuery AI functions to unlock that value. You'll see how to set up the configuration to connect BigQuery to Gemini, and then we'll run a few queries with different AI functions. And don't worry, you don't have to write any code to use this. It's all just SQL. All right, let's get started. We're in BigQuery in the Google Cloud Console, and I'm ready to start doing my AI.GENERATE functions. But first, I actually need to connect BigQuery to Vertex AI and set up a service account so we can do this. This is a few steps, but it's just a one-time setup, so once you've got it, you don't have to worry about it again. Now, to find this connection, I'm going to go to the Explorer and add data. This is just a way we'll connect Vertex AI to BigQuery and do that BigQuery federation. This will allow me to connect to the remote AI models in Vertex AI and also any remote functions for Big Lake. I'm naming my connection Vertex AI connection, but again, call it whatever you want. And I'm also putting it in the US region. I will create this connection and I need to go to it because it has made a service account. You can click go to connection, or if that disappears, you can also just find it in the side pane. And now I have this new service account, which is going to connect Vertex AI to BigQuery. But it does not have any permissions yet, so let's go to the IAM panel, the IAM page, and set that up. So I'll grant access to it, and we need to give it the BigQuery connection user and the Vertex AI user. That policy is now up to date and might take a minute or so to activate, so you may have to wait just like 60 seconds if you already had your query run and weren't ready yet. That's all the setup we have to do, and now we can start getting into some of the fun queries. The first data set I want us to look at is a set of movie reviews on IMDb. I'll just run this so we can take a look at what's in here. We've just got these kind of like long text reviews of what people thought of this movie. Now, the first query we're going to look at is the AI.GENERATE function. So this allows you to analyze any combination of text and unstructured data from BigQuery. You can do classification and sentiment analysis. Here, I want to use it to get some keywords on these movie reviews. That way we could maybe filter on them or do something more with them later. The syntax for this is going to look like AI.GENERATE. Then I will put my query in here. I can put the review column that's going to come out here. Then here's where I'll specify that connection ID that we just created. And I also need to pick an endpoint, so whichever AI model I want to be using. I'm just going to use Gemini 2.5 Flash. And I also just want to get the result from this because it will return a few different fields. I can now run this. It's not going to be as fast as just a select statement, but we should get the result in just a few seconds. All right, and now we've got this new column which has the results extracted from the review. So we can see there's some gore in this, an action flick, a hero flick, island settings, some of the actresses and actors. And this is a really good job. If you were to take this movie review, throw it into Gemini, and ask it for keywords, it would return this. But we're in BigQuery. We want to be able to interact with this data. So I think the next most important thing here is the output schema. So I want this to be returned as a keyword, as an array of keywords. That way it can filter on it or do joins on it, or just have a bit more flexibility with that. So to have it return as an array of strings, I'm going to use the output schema field, and I'll return it as an array of strings. And now, because I'm returning the output as keywords, instead I'm going to have to get keywords from that instead. We'll run it again. We've got our array of keywords. So each of these is now, its keywords is now a string array field, which is great. So we could take this, put it into its own table, do filtering on which keywords are in each of these things. I think there's a lot of potential of what you can do with this. AI.GENERATE is the most simple, basic thing you can do with an LLM in BigQuery. Let's take a look at some of the more advanced configurations we can do. So here, I'm just taking one specific movie ID and I'm getting the URL of that IMDb page. And I want to know, what is this movie about? And it said the movie on this page is A Beautiful Mind, a biographical drama. And, it did a great job of giving me this description, but it would be great if that was actually the movie that was there, because the movie I actually had to search was the 2002 Scooby-Doo movie with Sarah Michelle Gellar and Freddie Prinze Jr. AI can hallucinate, so what can you do to prevent that? I'm asking you to kind of look up this URL and get some information about it. So I'm going to give it a tool to use Google search as part of this query. I can add the model params field. And now one of the tools I'm providing is Google search. So now instead of just guessing what's on that URL, it's going to search for it. Let's run it and see how that goes. And now it's found that IMDb page has the movie Scooby-Doo 2002 American mystery adventure comedy horror film. So that is one way to bring some more real-time, realistic results to your queries if it's going to be data that might not be as obvious. There are tons of model parameters that you can do here, adding tools, adding different configurations. Here is one of the pages that has a lot of these different ones. So, if you're really wanting to get advanced in what you're going to do with your configuration, this allows you to do all of that. For example, if I'm wanting to seed in my model, so every time I run it, I'll get the same result, I can just use this generation config. There are so many different options of how you can configure this. And I think that just gives you a lot of flexibility, from just the basic ask a question all the way down to setting a seed, setting a amount of thinking parameters, setting the top K. There's so many different parameters with LLMs. It's great that this allows you to configure all of them. We've been generating a ton of text here. We've been getting descriptions and keywords, but not all of the things you're going to want to do are text. I think probably filtering on numbers or booleans is probably a much easier thing to filter on and manage, and really gets a lot of value from your data. So let's take a look at a more numerical data set for us. Here I've got the set of tree species in New York City. I'll run that. So, we've got just 57 different kinds of trees here. And AI.GENERATE has a few kind of cousin functions. So there's AI.GENERATE double, AI.GENERATE int, and AI.GENERATE bool. And, they're going to look pretty similar to AI.GENERATE, except now they've got the type right after it. Instead of returning a string when I put this in, now I'm asking it this question of, what is the average height in meters of this tree at full maturity? And just returning that as average height. I just had the names of these trees, right? I didn't have, here's this paragraph about this tree, let me extract that data from it. Gemini does have a good amount of general knowledge it's able to pull from, and that's how it's able to answer this question. So now we've got this column that's answering this question, and we could filter on it and do so many things with this. So let me put a few other queries in here. So we've got AI.GENERATE int and AI.GENERATE bool. I'm going to get the average life of this tree. And then also I'm going to see if this tree is drought tolerant. This just opens up so many different queries that you can run of, I want the tallest tree that's going to be drought tolerant, that lives to be 100 years old. And now I have all this additional data that I could have looked up. I could have asked Gemini or researched all of this, but I was able to get 57 answers times 3 automatically. And I can even take this, I can take each of those queries and just put them in the where clause. So to do exactly that, let's say I want to find trees that are going to be between 10 and 20 meters tall, because, got to find the right height for a tree. But trees that will live longer than 19 years, got to protect that investment, and also drought tolerant to continue protecting that investment. And here we've got this list of trees. So they're just sorted by any order, but I could have a Turkish filbert, I think. Or a green ash. I'm sure all these trees would be wonderful. Maybe I'd have to add more parameters if I want to filter more. Now, AI.GENERATE and AI.GENERATE bool and int and double, these take one data point and create another. But maybe you've got a series of data and want to predict that next series. So we can use AI.FORECAST for that. This is a bit more of an advanced one, but I just want to show you so you can see what's possible. This function is powered by Times FM, which is a foundational model from Google Research. It's been trained on 100 billion time points from the real world. And it just has a really accurate way that you can forecast data without ever having to train a model yourself. This is just a huge change from having to take your data, train on a small set, create that model, host it, manage it. You can really just start right away. So let's take a look at time series data. I've got this set of bike share rides in San Francisco. I'll run it. And we can actually look at the chart. I think that makes it easier. So here we see there's a pretty clear pattern here. But if you were to ask Gemini, what's the next one? It might not be able to do as good a job understanding the nuances of the pattern. I think with any time series data, visualizing it is probably one of the best ways to do that. So we've got a Colab notebook, which actually has a few of the other queries I've showed already. And you don't have to use Python to do any of this, but I think it makes it a little easier. So here we're taking that same query we got, just selecting the bike shares from a certain date and grouping them by subscriber type. And then we're using AI.FORECAST. And here I've set the horizon to 720. So that's going to be in hours. So it'll be about 30 days. And if I run this, I will get those predictions. And you could take this query and just also run it in BigQuery as well, just the same as SQL. But I think here I'll actually show you what the results look like. So we get the forecasted value for the specific timestamps. We also get that confidence level that I've specified in my query. And I also love that you get this prediction lower bound and the prediction upper bound. So you can really have a good range of what that prediction is. So you can see, okay, it's pretty confident it'll be right near there, or it's going to be like, okay, it'll be somewhere within this range. And I think this is most obvious when we graph it out here. So let me run this. Now we can see the forecast of these trips. So the orange line is the subscriber forecast. The blue is the customers. And if you look closely, or I'll just zoom in a little bit, these shaded lines show you that confidence interval. So in some places, the confidence is pretty small, but in some, it goes out a lot more. But this is just such a cool way that you can start visualizing this data, generating time series results, predictions, and really just have access to forecasting without needing a whole data science team. Now, this is actually part of an entire Colab notebook, which has a ton of instructions on how to get set up with all of this. Going to walk you through setting up your project, setting your project ID, authentication, getting your service account set up. I did it in the UI because that's how I like to do things. It's a little easier for me, but this helps you get all those IAM permissions set up. And it's going to walk you through a lot of the queries I showed here. We also show you a few other things like AI.GENERATE table in here and ML.GENERATE text. So ML.GENERATE text is great if you want to use a partner model. So maybe you want to use Claude or Gemma or just any of the open source models. This gives you a lot of flexibility. So I'll link this so you can try it out right away. There are tons more things I can show you with this. So if you have any specific requests, definitely comment them. I know I want to show some stuff about how to process audio with this or images. All sorts of multimodal things are possible too. So there's definitely a lot of stuff here. And let me know if you have specific areas you want help with. And if you do go try this out and play around with some public data sets and do something cool, you should definitely consider submitting to the AI hackathon that we're running for BigQuery. There are $100,000 in prizes. Just go and take a public data set and use some of the functions I showed. That's really the whole challenge. So it's a pretty easy way if you're already playing around with this to just submit something and, maybe you win some money, which would be pretty cool. I hope this video was helpful for you to see the process to get things started up, to run some of these queries and see what's possible. Thanks so much for watching. Bye.